Today's video is on the problem related to Laurent series, and this topic is from complex power series. In today's video, I am going to expand 1 by z into z square minus 3z plus 2 in the regions. First one, 1 less than or equal to mod z less than or equal to 2. And the next one is 0 less than or equal to mod z less than or equal to 1. And next one is mod z greater than or equal to 2. So, from the function, so what is f of z given? So f of z is given as 1 by, this is z into z square minus 3z plus 2. Clear? Now if I take the factors for this, so what will happen? So z square minus 3z plus 2 can be written as, this is z square, so 2, 2 ones are 2, that is minus 2z minus z plus 2. So if I take z common, so this will be z minus 2. If I take minus common, this will be z minus 2. So if I take z minus 2 common, this will be z minus 1. Therefore, f of z is equal to 1 by z into, this is z minus 1 into z minus 2. Clear? Now I am going to resolve into partial fractions. So f of z I am writing as, this is a by z plus this one is b by z minus 1 plus c by, this is z minus 2. Now I need the values of a, b and c. So in order to get the values of a, b and c, see here, this is a by z plus b by, this is z minus 1 plus c by z minus 2. So if I take LCM, this is z into z minus 1 into z minus 2. So this will be a times of, so a times of c, a into, this is z minus 1 into z minus 2 plus b times of, this is z into, this is z minus 2 plus c times of z into z minus 1. This is z into z minus 1. Now see here, what is this one? So this one is 1 by z into z minus 1 into z minus 2. Here also a times of z minus 1 into z minus 2 plus b times of, this is z into z minus 2 plus c times of z into z minus 1 by, this is z into z minus 1 into z minus 2. If I cancel the denominator, and what is the numerator here? In LHS side, this is 1. Therefore, 1 is equal to a times of z minus 1 into z minus 2 plus b times of, this is z into z minus 2 plus c times of, this is z into z minus 1. This is z minus 1. So if I put z is equal to 1, see what I am going to get. So put z is equal to 1. So if I keep z is equal to 1, so this will be 0, this will be 0. What remains here? 1 is equal to 0 plus b into, this is 1 into, this is 1 minus 2 plus 0. Therefore, 1 is equal to, so this is minus b. So we got the value of b as minus 1. Clear? Next one, if I put z is equal to 0, this time put z is equal to 0. So then this will be 0, this will be 0. What remains here? So 1 is equal to a into, this is 0 minus 1, this is 0 minus 2. 1 is equal to, so this value is 2a and a value is 1 by 2. So we got the value of a as 1 by 2. And next case here is put z is equal to 2. So this is z is equal to 2. And see, this will be 0, this will be 0. Therefore, the value here is 1 is equal to c into 2 into, this is 2 minus 1. So this is 1 into 2 minus 1 is 1, this will be 2c and c value is nothing but half. So we got the value of c as half. So after getting a, b, c, so what is our a value? This is half, b value is minus 1, c value is half. And now I am going to substitute here as a value is equal to half. So a value we got as half, b value is minus 1 and c value is again half. So what will be our f of z? So our f of z value will be, so after substituting the values, this will be f of z value is equal to, so f of z is equal to, this is half by z, and this is minus 1 by z minus 1, and this is half by z minus 2. Clear? And now our f of z value is ready here. So f of z is equal to, this is 1 by 2z minus 1 by z minus 1 plus 1 by 2 times of this is z minus 2. And the first case here is, see here, what is the first case here? That is 1 less than or equal to mod z less than or equal to 2. So the case 1 here is 1 less than or equal to mod z less than or equal to 2. So for this case, so what will be our Laurent series expansion? So f of z is equal to, so f of z is equal to, this is 1 by 2z. Among z and 1, see here, among z and 1, which one is greater one? Z is greater. Now I am taking z common. See, this is 1 by 1 minus z. Clear? This is 1 by 2 times of, among z and 2, which one is greater? 2 is greater. That's why I am taking 2. Here minus 2, if I take common, this will be 1 minus z by 2. So f of z here is, this is 1 by 2z minus 1 by z into 1 by z inverse. So this is minus 1 by 4 times of, if I send it to the numerator, this is 1 minus z by 2 inverse. Now I am going to expand this one. So f of z can be written as, this is 1 by 2z minus 1 by z times of, this is 1 plus 1 by z plus 1 by z square plus and so on. Here 1 by 4 times of, here this is 1 plus z by 2 times of, this is z square by 2 square plus and so on. So this can be written as, so f of z can be written as, f of z is equal to, this is 1 by 2z minus 1 by z times of, this is sigma n is equal to 0 to infinity 1 by z bar n minus 1 by 4 times of sigma n is equal to 0 to infinity, this is z by 2 bar n. So this is the Laurent series expansion for this one, that is 1 less than or equal to mod z less than or equal to 2. And next thing here is, the condition here is 0 less than or equal to mod z less than or equal to 1. See here, 0 case 2. So second question here is 0 less than or equal to mod z less than or equal to 1. Here our f of x function is this one, that is f of z is equal to, see, f of z is equal to, this is 1 by 2z, 1 by 2z minus, this is z minus 1 plus 1 by 2 times of z minus 2. Clear? So in this case, so again f of z can be written as, so this is 1 by 2z on comparing with z and 1. See here, this is z and this is 1. So in this case, which one is greater? 1 is greater. Therefore, I am taking 1 common. So this will be, if I take minus common, this will be minus 1 by z. And here in this case, so this is still greater than or equal to 2. Z is greater or 2 is greater? 2 is greater. That's why I am taking 2 common from this. So this is 2 times of, if I take minus 2 common, this will be 1 minus, this is z by 2. Clear? So f of z is equal to, this is 1 by 2z plus, if I send it to the numerator, this will be 1 minus z inverse. This is minus 1 by minus 1 by 4. This is 1 minus, this is z by 2 inverse. So f of z, so f of z is equal to, this is 1 by 2z plus, so this is 1 plus z square plus and so on, minus 1 by 4 times of, if I expand this one, this is 1 plus, this is z by 2 plus, this is z square by 2 square plus and so on. So f of z can be written as, so f of z can be written as, this is 1 by 2z plus sigma n is equal to 0 to infinity, this is z bar n minus 1 by 4, sigma n is equal to 0 to infinity, this is z by 2 bar n. So this is the Laurent series expansion for the condition that 0 less than or equal to mod z less than or equal to 1. And the next case here, the third case here is mod z greater than or equal to 2. So for mod z greater than or equal to 2, so for C condition, our f of z is very clear as, See, first of all, we have to write f of z value. So what is our f of z value? So this is this one. F of z is equal to, see, f of z is equal to, this is 1 by 2z minus 1 by z minus 1 plus 1 by 2 times of z minus 2. And the third case here is mod z. See, the third case here is mod z is greater than or equal to. It is still greater than or equal to 1. Clear? And therefore, f of z is equal to, see, this is 1 by 2z minus, among z and 1, which one is greater? Z is greater. That's why I'm taking z common. This will be 1 minus 1 by z. And this is 1 by 2 times of among z and 2. Which one is greater? Z is greater. Here also I'm taking z common. This will be 1 minus, this is 2 by z. Clear? So f of z is equal to, so f of z value is equal to, this is 1 by 2z minus 1 by z times of 1 minus 1 by z inverse plus 1 by 2z into, see here, this is 1 minus 2 by z inverse. 2 by z inverse. Therefore, f of z is equal to, f of z is equal to, this is 1 by 2z minus 1 by z. If I expand this one, this will be 1 plus 1 by z plus 1 by z square plus and so on. And next one, this is 1 by 2z times of, if I expand this one, 1 plus, this is 2 by z plus, this is 2 square plus z square plus and so on. Plus on, so on. Therefore, f of z is equal to, f of z is equal to, this is 1 by 2z minus, this is 1 by z times of sigma n is equal to 0 to infinity 1 by z power n plus, this is 1 by 2z times of, this is sigma n is equal to 0 to infinity 2 by z power n. So this is the expansion for the case mod z greater than or equal to 1, greater than or equal to 2, greater than or equal to 1. See here, in this question, what is given? So we have to expand 1 by z into z square minus 3z plus 2 in the regions. First region is this one, 1 less than or equal to mod z less than or equal to 2, and second region and third region. First of all, I am modifying this f of z. So you, after taking the factors for this is z minus 1 into z minus 2. So after resolving into partial fractions and cancelling the denominator and equating the numerators from LHS and RHS. So if I put z is equal to 0, I got b value as minus 1. If I put z is equal to 0, I got a value as half. If I put z is equal to 2, I got c value as plus half. So the first case here is case 1. So this is after substituting a value, b value and c value. So this is case 1, that is 1 less than or equal to mod z less than or equal to 2. So after substituting all the values, see, among z and 1, z is greater, therefore I have taken z common. Among z and 2, which one is greater? 2 is greater, I have taken minus 2 common, and after expanding, this is the Laurent series expansion for that case. And 0 less than or equal to mod z less than or equal to 1. So in this expansion also, among z and 1, among z and 1, 1 is greater. That's why I have taken minus common here. And among z and 2, so here 2 is greater, so I have taken 2 common, and after expansion, this is the Laurent series expansion. And here f of z is this one, and the third case here is mod z greater than or equal to 2. If z is greater than or equal to 2, z is even greater than or equal to 1. And therefore, among, see here, among z and 1, which one is greater? Z is greater. So I have taken z common. Among z and 2, z is greater. So I have taken z common. So this is the final answer according to the Laurent series. Thank you so much for watching, and this is a most important question. And please go through my playlist, and it will be very helpful for your preparation. If you really like, pass it on to your friends. Thank you so much.